we're going to take a look at example 7 now, and we're going to graph some of these. Okay, and there's a few ways to do this. I think the easiest way is to pick some points from the exponential function and then to swap the domain and the range and then plot those. But I'll kind of show you what I do. There are more than one way. There's more than one way to do this, obviously. All right, but this is one of these things that we're moving, that we're that's going to have a transformation on this. So what is this doing to the overall graph? Well, that's going to be a vertical shift down, okay, is what's going to happen. All right, so to start with, what I would do is I would look at the inverse, which is y equals 1/3 to the x. Okay, let's pick a few points from that. Okay, so if we said -1, we could say -2, -1, 0, 1, 2, okay? All right, when x is -2 here, what's y going to equal to? Well, that's going to be, it's going to be 1/3 to the -2 power, which is the same thing as 3 to the +2 power, which is 9, okay? So 1/3 to the -1 power, same thing as 3 to the +1 power, so that's 3. Okay, 1/3 to the 0 power, well, that's still 1. 1/3 to the first power, well, that's 1/3, right? And then 1/3 squared, that's going to be 1/9. All right, so my untransformed function, without doing the vertical shift of y equals log 1/3 x, is going to look like it's just going to have the domain and the range swapped from the inverse of the, its inverse, the exponential function. So in other words, I'm going to copy the y values over here into the x. So I've got 9, 3, 1, 1/3, 1/9 as inputs. And then my outputs are going to be -2, -1, 0, 1, and 2. And that's kind of what I'm going to plot here. So I'm going to just kind of plot these points, and then I'm going to do the transformation of moving everything down 1. So when x is 9, y is -2. This is just right here. When x is 3, y is -1. When x is 1, y is 0. When x is 1/3, and I'm just sort of guesstimating here, I'm going to get here at 1. When I'm at 1/9, so it's going to shoot up here. This is my vertical asymptote. It's going to get real close to the y-axis. That's x equals 0 here. So remember we said our domain was going to be everything to the right of x equals 0, and I'm going to have a vertical asymptote at x equals 0. And so this is going to kind of shoot up and go over. But now I've got to go ahead and put my vertical shifting in here down. So everything's going to go down 1. This goes down 1. This goes down 1. This goes down 1. And now I sketch my graph. It's going to go, it's going to do something like this, okay? And so there it is. So that's what this is. All right, so let's take a look at it in terms of domain and range, okay? We were talking about the fact that we have a vertical asymptote, right, at x equals h. In this case, h is 0. There's no horizontal change at all. So it's x equals 0, which is my y-axis, right? It gets really, really close to the y-axis, but it never touches it, and it kind of shoots off to infinity, real close to the y-axis, but but to the right of it. So what's my domain then going to be? My domain, since I don't have any negative values of x, my domain's going to be all reals for x greater than 0, because all my x values are going to be here to the right of my y-axis. What's my range? Now keep in mind these arrows actually are going on forever and ever and ever. So my range is going to be all reals. Okay. Now keep in mind, remember the logarithmic function here is the inverse of the exponential function. Remember when we were graphing exponential functions, what our domain and range was there. Remember we had all reals was in the domain, and that maps to the all reals in the range of my inverse, right? and then in my my range here, I had all positive values. Well, yeah, right here, all positive values, and that ties to here my domain, x being positive. Okay, so since they're inverses, the domain and the ranges, they're have the inverse characteristics as well.